Hello, my name is Austin Chan. I'm a data scientist at a small education nonprofit in Sacramento, California. And for my Data 698 capstone project, I researched associate's degree pathways to success. So looking at the demand for associate's degree graduates in the workforce. So day to day, I work with a lot of community college data. I take a look at the courses that students take, what kind of awards they're getting, if they're graduating, what kind of GPAs they have. And I build these dashboards which show basically these statistics for every community college in all of California. And a lot of the feedback that I get from people who use these dashboards is they tell me that all of this information is great, but it's not up to date. It's really old data. This is data from a year ago, and my students have already graduated now. They've already gone out to the workforce, or I don't teach them anymore, so I can't really respond in time. And so the problem is that with these dashboards, there's not as much emphasis on providing on-demand data analysis, even though this is what people actually want. So the problem here is that uh, specifically with community college students, when they're picking majors, they really want to pick majors that have workforce demand, where that they're able to get a job after they graduate. And so without up-to-date data, there's no way that they could really find out what jobs are in demand and what majors that they should focus on in order to, get a job at the end after they graduate. So my problem statement is as follows. So community college students are unsure about what type of certification they should pursue in order to obtain a living wage because they lack up-to-date information about the regional supply and demand for associate's degree graduates in the workforce, the number of positions they have access to at their experience level, and the salary expectation for each type of certification. So my solution for this problem is to create a data analysis pipeline. So what is a data analysis pipeline? So a data analysis pipeline is a set of programming scripts that collect, process, and analyze data with minimal input from the user. So I wanted to see if I could create a system that could perform on-demand data analysis so that students can have the data they need to make informed decisions about their education regarding workforce patterns, where they live. So I really like data pipelines because they're very streamlined. They're very they could take unstructured data and turn it into structured data. They have a lot of flexibility with the technologies they can use. They can use R, Python, SQL, JavaScript. Put it all together into one thing that can create analysis from completely raw data. So a lot of my literature review focused on how to design the pipeline. So I looked at a lot of economic models that work with workforce supply and demand to see, kind of the theoretical basis for, creating a tool like this. So I also researched what features I'd wanted to include as well, what things would be relevant for some pipeline like this. So at least for this part, um, I had to pick between a couple different models. So the most common models were top-down forecasting and labor market signaling. Um, and so ultimately, I ended up choosing labor market signaling because it employs a student-centered approach instead of an industry-centered approach. It measures the economic returns for certificates and credentials. It highlights the disparities in employer demand, and it really requires not a lot of data. And so for a project that focuses on education data and workforce data that is very, very sparse, this model is very appealing for that kind of approach. And so in terms of like design considerations, for a pipeline like this to be useful, it needs to be fast, it needs to be agile. And the main problem for most data tools is that they rely on fixed data sets that are updated annually. So by the time updates come to address issues, it's too late because the data is too old to be relevant. So in order to address that problem, I looked at ways I can get data on demand, data as soon as possible. So what I found was that web scraping was a really good technique for this because you're able to take data directly from websites whenever you want, um, and just constantly have data that's always up to date whenever you need it, and that you can use it to fuel your data pipeline. And so another feature that I thought would be really important is that the pipeline must be adaptable to market trends. So given that the job market is like constantly shifting, employers are always asking for like, oh, what's the new hot thing that I could get someone to do? So maybe, right now it might be data science, and later it might be something else. And so this pipeline needs to be able to adapt to those market changes. So the way that I did that was I I used a classification method which is easily tunable. It's called regular expression text classification that allows me to classify words just based on using strings, using phrases that I could easily adjust whenever a new type of job enters the market. I can just change that really quick to start classifying those new jobs and just adding more and more expressions to create more and more classification. And it's really quick, it's really easy, and it's really adaptable. And so this drove a lot of the overarching design. So I wanted a pipeline that had on-demand data, so I had to use web scraping. I wanted it to be able to classify new positions really easily, be able to be adjustable. So I used regular expressions. And then in terms of the kind of data processing element, I wanted something that was really, really flexible, but still really structured. So with this, I used SQL or SQL. And then for visualizations, I wanted to keep it really clean, keep it really usable for people who are not necessarily data folks. So stuff like bar plots, box plots, histograms, things that are easy for people to understand, easy for people to look at. So regarding the specific parts of it, my first part was the web scraping part. So web scraping is the use of programming languages or software to extract metadata from web pages on the internet. So underneath a lot of, or pretty much every web page is a programming language called hypertext markup language, or HTML, which basically formats a web page and fills in all of the content on the page. And so what you can do with web scraping is that you can take all of that HTML code and process it so that you could transform what's on the web page into a structured data table, into like a CSV file, into a data frame in R, and then run analysis on it. And so I did this on two websites. The first one was Indeed.com, which is a job posting website. I was able to scrape job descriptions from that website. I put in, I wanted to look for jobs that were entry level, that were full time, within 50 miles of the city, and required a associate's degree or high school diploma, and had a salary at or above the living wage for the area. So I wanted to look for jobs that associate's degree graduates would prefer, that they want to get, that would enable them to survive where they live, right? So in order to get the living wage, I scraped the MIT Living Wage Calculator website, which has a breakdown of the cost of living in any county in the United States. So it would account for factors like food, like health insurance, car maintenance, housing, childcare, taxes, and miscellaneous costs, and it would combine all of those costs into one big number that says, okay, the cost of living in this area, to survive in, for example, Sacramento County, this would be like $26,685. And so what I would do is I would take that number that I got from the MIT Living Wage Calculator and feed that into the Indeed web scraper so that I could find jobs that were guaranteed to have above a living wage for any given area in the United States. So after I gathered all of that job data, I had to classify it. So I used natural language processing to determine which keywords I should classify for different certifications. So right here has a box plot, or not the box plot, my mistake. This is a word cloud of the most common job postings that I found in the Sacramento area in California. So in here we can see there's a lot of nursing positions, there's a lot of technician positions, a lot of specialists, a lot of teachers. And so using this word cloud, I can take a look at which positions were most common and then create regular expressions to classify out those job postings. So for example, for nurses, I had to look for, whether the word nurse or nursing was in the job title so that I could classify those as nursing positions. And then for trades, I had a regular expression for that. If, a job required a certification, I had a regular expression for that. So being able to classify jobs by their certification type allows for further analysis by certification type. And so what I also did with regular expressions was that I extracted the amount of experience each position required. So if it required 2 years of experience, I extracted every sentence that said X amount of experience required and then extracted the number so that I could see, okay, if something required 2 years of sales experience, I would make sure that that position required at least 2 years of experience. So after classifying the positions, I needed to compare them to education data to see if the supply and the demand, met each other. So I used some data from the U.S. Department of Education called the College Scorecard data to calculate the number of associate degree graduates produced per year. So unfortunately, this data set did not explicitly state the number of associate's degree graduates per year, so I had to calculate it using the student count and the graduation rate. So if you multiply those two together, the student count multiplied by the graduation rate, you should get the number of students who graduated. And so since they only had the 8-year cohort, what I had to do was I had to take the number of students who were enrolled multiplied by their 8-year cohort graduation rate to produce the number of graduates over an 8-year time span. So then I had to take that number and then divide it by 8, which produces basically an average of the amount of associate's degree graduates per year. And so using that number, I could compare that to the number of positions available to associate's degree graduates per year to see if the supply and the demand match up. So in order to visualize these data, I used bar plots, I used histograms, and I used box plots. So the advantage of bar plots is that they're very interpretable, very easy to read, and they do really well with count data. I used histograms because they show distribution data really well. They show kind of the shape of the distribution, the min, the max. You're able to see kind of the what maybe salaries are most typical. What range of salaries is kind of existing within a certain set of jobs. And so I also used box plots because box plots are really good for comparing between distributions. So in this chart right here, we could see, nursing distribution is different from trade, which is different from license, and so on. So with this analysis, I wanted to answer these following questions. So does the supply of associate's degree graduates meet the demand in the workforce for associate's degree graduates in my local region? How many positions do associate's degree graduates have access to based on my level of experience and type of certification? And then what is the expected yearly salary for each type of certification? So for the first question, I found that there were 4,895 associate's degree graduates per year on average. I also found that there were 5,052 entry-level positions advertised per year on Indeed.com for associate's degree graduates. So the number of associate's degree graduates matches the number of available entry-level positions. And an interesting caveat to this is that this result only holds if it includes positions that prefer an associate's degree but don't explicitly require one. So regarding the second question, so looking at how many positions do associate's degree graduates have access to based on level of experience, I found that associate's degree graduates who have at least 1 year of related work experience have access to 81% more positions than associate's degree holders who have no related experience. And so this is an interesting finding because you would think that certification would be something that gives you like a pretty significant edge in the workforce, but what really matters a lot is just the raw number of years of experience. If you're able to have a year of experience, you can get so many more jobs than if you had no experience, right? And not to say that certification is useless. I also found that certification grants 19% more jobs, for people compared to graduates who do not have any kind of certification at all. So they only have their associate's degree. Um, yep. So what is the expected yearly salary for each type of certification? So right here on this box plot, we could see that we have the median salaries for each type of certification. So for nursing, I think the median salary for all the positions was approximately $60,000, and then for trades it was about $48,000, and then for certifications and licenses like that are not trades and nurses, it was about like 34,000, and then for no certification it was 32,000. So what I found from this is that certification really does add a lot to your salary. It gives you access to positions that pay significantly more, especially for nurses and for trades. So right here we could see the 95% confidence interval of the difference between the salaries for nursing positions versus the salaries for associate's degree positions that don't require any other certification. So um, this confidence interval is somewhere around like $19,000 to up to $38,000 more, which is a huge, huge jump. And then with trades, we can see that there's a difference of about $1,800 to $14,800. So sometimes some trades may not pay as much, but they could also have the potential to pay significantly more than just having a regular associate's degree. And then for licenses, the gap is a little smaller, but still pretty significant. So what I wanted to look at next was entry-level jobs. So seeing the income distribution for jobs that don't require, that much experience. So jobs that were kind of within reach for associate's degree graduates. And what I found was that there is not a significant difference between, if you have 0 years of experience versus 1 versus 2, your salary is pretty much the same regardless or within your certification. So right here we can see the nursing salaries are relatively similar to each other. The trade salaries are basically the same. The certification and license salaries are also the same. And so this is surprising because you would expect that when you have more years of experience, your starting salary would be higher, but at least for entry-level positions, this doesn't appear to be true. So we've come to the end. So in this project, I applied web scraping, natural language processing, relational databases, and statistics to create a workforce pipeline that analyzes workforce data and education data and kind of puts them together into one thing so that students won't have to rely on static data sources. They can, use this tool to take a look at what job postings are available right now. They can look at what skills are required for those job postings. They can look at how much those positions pay, all on demand, all instantly, right? They can scrape the positions themselves, run the analysis. This all can happen in under a day, which compared to the year-long wait time that takes for dashboards or statistics from the U.S. government, having a one-day turnaround is significantly fast, and that allows students to really leverage the power of data. It allows students to take information directly from the internet and use that to inform their decisions, to inform what kind of major they're going to choose, what kind of profession they're going to have, and having like on-demand data is really valuable. So using this data analysis pipeline, community college students can understand which skills and certifications are relevant and adapt to those changes as they happen. So yep, that's my project. Thank you for listening.